Hey, geometry students, trust each of you did well on your test that you took from me yesterday and you're ready to get started into some new material. Today we're going to be working on lesson 91 where we're going to talk about an introduction to trig identities. Now we have talked about three different trig relationships before, or trig ratios, and those were sine, cosine, and tangent. What we're going to notice today with this idea of a trig identity, there's some different expressions or equations that relate two of those trig functions at a time. There will be one equation that we're going to notice that relates sine and cosine, and then a second equation that we're going to notice actually relates all three of our trig ratios to each other, sine, cosine, and tangent. The entire lesson is based off these two relationships, so please make sure you definitely write down these two identities for me. The first one is the one that involves all three ratios, and it's the fact that tangent is equal to sine divided by cosine. Remember that little symbol there I have is theta, that's an angle. So the tangent of some angle is the same idea as me taking the sine of that angle and divided by the cosine of that angle. Just to show you real quickly why that is the case. What was our definition of sine? The definition of sine was opposite over hypotenuse. I'm just going to say O over H. So the sine ratio was opposite over hypotenuse. Well, that's all over the cosine ratio. What was the cosine ratio that we learned? Remember our SOHCA-TOA. The cosine ratio was the adjacent over the hypotenuse. Well, notice what I have written here is a fraction divided by another fraction. How do I correctly divide with fractions? I multiply by the reciprocal. So I'm going to keep the first fraction. I'm going to keep my O over H for my opposite over hypotenuse. Then I'm going to multiply by the reciprocal, which means I'm going to flip the bottom fraction around. When I flip that bottom fraction around, it's now going to say H over A. Well, now that I have it written as that multiplication problem, notice what can happen. The H that is here in the denominator cancels the H that's up here in the numerator. What am I left with? O over A, which is opposite over adjacent. And what was opposite over adjacent? It was the tangent ratio. So that's why that first one is true. That sine divided by cosine is the same thing as our tangent ratio. The second ratio, or the second identity that we're going to spend most of our time focused on is this one, sine squared x plus cosine squared x equals 1. Now, don't worry because it says x here. If you wanted to write, you could say sine squared theta plus cosine squared theta equals 1. It's really irrelevant what symbol we have behind the sine and the cosine as long as there is some sort of angle that is sitting there in the question. So again, sine squared x would be the same thing as sine squared theta if you prefer to write it down like that. The textbook on the homework is going to use the theta, so if you want to do that, you could in the problem. Let me show you why this one's true as well. Again, this isn't something necessarily that you have to repeat to me, but I want you to understand where these identities do come from. We already saw the first one. We changed sine and cosine into their definitions, and then we multiplied by the reciprocal, and that left us with our tangent definition. Well, showing why does sine squared x plus cosine squared x equal 1? Well, notice what I have here is a right triangle because trig always has to deal with right triangles in your question. If I look at the right triangle, here's the x, here's the angle that I've decided that I'm going to go from. What was our sine definition? It was opposite over hypotenuse. So from the angle x, the opposite side is the letter A, the hypotenuse is the letter C. So the sine ratio would be A over C. And notice I have A over C squared because it says sine squared of whatever the angle was. Cosine, beginning again at our angle x. What is our cosine ratio? Adjacent over hypotenuse. So from the x, the adjacent side is the letter B. The hypotenuse was the C. So I have B over C. And once again, that's squared because it said cosine squared. And now our equation still equals 1. The next thing I want to do as I continue working through this proving or showing that this is actually a true statement is I'm going to square both of those fractions. Now, when you square a fraction, the square applies to the numerator and denominator. Remember, to square means you're multiplying it by itself. So a over c squared is really a over c times a over c. Well, what's a times a squared, and what's c times c squared. So notice the square just went into both the numerator and denominator. The same thing happens on my second fraction. B over c squared, that would be b squared all over c squared. The equation still equals 1. There's nothing that I can do on the right-hand side of the question. Now, the next thing I want to do to help you kind of show why this is a true identity is I'm going to knock out the fractions that I have in this question. Well, that's something that we know how to do. We learned that during algebra. What can I do to eliminate all of these fractions? I would multiply by the common denominator. The common denominator that I have in this question is c squared. That's the only denominator that I have. So I'm going to take the entire question and I'm going to multiply it by c squared. Now, notice what happens when I do that. The c squared that I'm multiplying by would knock off the c squared that's in the denominator. And if you need to, you can put this over 1. That way you can see the c squared's in the numerator. That's why it cancels with the c squared in the denominator. What am I left with from the first term then? I'm just left with the a squared. Drop down the plus sign. The same thing happens on the second fraction. The c squared that I'm multiplying by would cancel the c squared that you have in the denominator, and that would just leave you with the b squared that you had in the numerator, and there's my equal sign. Now, even though this last part isn't a fraction, you still need to multiply by the common denominator, so c squared times 1 is c squared. What did I just write down? A squared plus b squared equals c squared. Each one of you know what that is. It's the Pythagorean theorem. We know that the Pythagorean theorem is true. Therefore, our original statement that sine squared of our angle, so sine squared x plus cosine squared x, does equal 1 in our question. Now, let me show you how we're going to use this identity. Again, this is the one that we're mainly going to be focusing on here in our lesson. The other one is true, that tangent was equal to sine over cosine, but we're going to spend most of our time focusing on this one. This would represent something very close to what you're going to do on letter A in your lesson practice for the homework tonight. It's going to say find cosine of theta if sine theta is equal to 0.4. Now, make sure you got your calculator handy for me because you're going to need to do some arithmetic along with me to make sure that you understand what's going on in the question. Notice the problem has a sine and a cosine. So how would I know which of the ratios to use? I would want to use the ratio that only involves sines and cosines. Well, what ratio was that? It was the second one that we wrote down, that sine squared theta plus cosine squared theta was equal to 1. So here I put it as theta instead of x. Again, that's irrelevant. I just did theta because this question had theta in its problem as well. What was given to me in the problem? It says sine theta was equal to 0.4. So I'm going to go into the question where I see sine theta, and I'm going to replace it with 0.4. However, in the equation, it says sine squared theta. So when I replace the 0.4 in, the exponent of 2 is still there in the problem. So I have 0.4 squared plus cosine squared theta is equal to 1. Notice all that you have left in the question now is that cosine, and that was the goal. You're attempting to find or to solve for what is cosine in the problem. How do I do this arithmetic? The first thing is taking my calculator and doing 0.4 squared. When I did 0.4 squared, I came up with 0.16. I still have my plus cosine squared theta is equal to 1. If I need to continue to solve for cosine, I need to get rid of that 0.16, so I'm going to subtract it to the right-hand side. 1 minus 0.16 gave me 0.84, so I have cosine squared of our theta is equal to 0.84, and our job is to find cosine, not cosine squared. Well, how do I get rid of a square in math? I have to square root. So I'm going to square root on both sides of our equation. The square root cancels the square from the left-hand side. And on my calculator, I'm going to type in the square root of 0.84, and I know that cosine theta is equal to 0.92. Now, one thing I do want to point out about what you're going to do on letter A, so make sure you listen carefully so you don't mess this question up. On letter A, it says if sine squared theta equals 0.67. Well, that means when you start the question, you can replace this entire sine squared theta. On our question, I just gave you sine theta, not sine squared. So we had to do the square still in the question. But the textbook problem is going to give you the entire sine squared. So you would actually start here kind of on this step where you're not going to do the square, just fill in the number that the question gives you, subtract it over, and then do your square root to finish up our problem. Now, what I would like to finish up with in today's lesson here, going back to our trig identities. At the beginning of this lesson, I gave you two main trig identities. The first one was tangent theta equals sine over cosine, and our second one that we've been using so far, sine squared theta plus cosine squared theta is equal to 1. From those two trig identities, more identities can be created by just simply rearranging some of the different parts and also substituting some pieces that we know in our question. What I would like to do is show you on one of those, how would I correctly do that? Then our book actually gives us the rest of them, and I'll show you where you can find those. Okay, so our job, we're going to express cosine using only the sine ratio. So what does that mean? I want a question now to say cosine theta equals, and what I have on the right-hand side of the question, I mean, it could have numbers, but it can only say sine. It can't say tangent, it can't say cosine on the right-hand side. The cosine is on the left-hand side because that's what I'm supposed to express. That's what I'm supposed to write in my problem. So cosine theta equals what? And on that what part of the equation, it says to express it using only sine. That's where I want my sine ratio to be. So how are we going to do that? Since this question involves sines and cosines, which one of our two basic trig ratios should we start with? The one that only involves sine and cosine, which is our sine squared theta plus cosine squared theta equals 1. So what again did it mean to express cosine? That means I'm trying to solve for cosine in the question. The steps that I'm going to take to solve are almost identical to the steps that we just took on that numerical equation where we try to solve for cosine in our question. If I want to get cosine by itself, the first thing I need to do is to get rid of the sine squared. How do I get rid of sine squared? I would subtract it to the right-hand side. 1 and sine squared aren't like terms, so I can't put them together. So the right side says 1 minus sine squared theta. Notice the right-hand side of the question has that sine theta, and that makes sense because I was trying to write the question using the sine ratio. We're supposed to be writing cosine, and the question currently says cosine squared. So how did we get rid of the square that was on our cosine? We square rooted. So what is the cosine ratio in terms of sine or using only sine? It is the square root of 1 minus sine squared theta. So that would be the answer. I've written cosine, I've expressed it as some sort of identity, as some sort of equation, and in that equation, I have only used sine. It's okay that I have a number sitting there, but I don't have a cosine ratio on the right-hand side, and I don't have a tangent ratio on the right-hand side either. If you were to go in your textbook to page 596, actually, why don't you go ahead and turn there for me, page 596. At the top of page 596, there's a block up at the top there, and what they did is they took each one of our three trig ratios and they wrote them in terms of each other. Okay, so what was sine in terms of cosine? It's almost the same process as this, because I would subtract the cosine and then I would square root. So you see 1 minus cosine squared theta. Some of them are a little bit more complicated to show you how they come up with that equation, so I'm not going to worry about that, but I did want you to just be able to see what are some of the other trig identities that we have. Again, the ones that you're responsible for are the two main trig identities from this lesson. Number 1, that tangent theta was equal to sine over cosine, and then number 2, sine squared theta plus cosine squared theta is equal to 1.